The broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, welcome back to Young Engineers of Today. I hope you're all doing well, and I hope you had a good week so far. I hope you are ready to continue with bridge building. Hey Cohen. Apologize if I'm being a little quiet right now. I'm dealing with a pretty monster headache, so trying to take it easy on the old noggin there. So I'm going to be a little bit more low energy than normal too. Anyway, hey Mateo. Thank you, Cohen. No worries though. Thank you. I appreciate it. I think I just need a good long lay down in a dark room before it gets more so. But that's very nice of you to offer that, Cohen. All right, so we've been working with bridge building. At least you guys have, and I believe Mr. Dubik laid out excuse me. My cat suddenly wants attention. He's trying to knock things off. I had to get him off the top of the fridge because, of course, he wants to get on top of the fridge right now. So I believe Mr. Dubik on Monday laid out the bridge building contest that he's got going on. Basically, just you want to build a bridge that satisfies the requirements that are in the bridge design contest software, and you want to make it as cheap as possible. That's basically the aim of this contest, is to make a bridge as cheap as possible that satisfies the requirements, which I believe are the two 225 kilonewton trucks. So that'll be the whole point of the contest. Basically, you just submit your designs to Edmodo with a breakdown of the costs, which the bridge should provide for you, the software should provide for you. You are more than welcome to submit. Are you running with the 400 and something kilonewton? Gotcha. Okay. What is the Edmodo code? That is a fantastic question. Let me see if I can't look that up for you. I don't. You can ask Mr. Dubik about that, Mateo, but I don't know for certain. Okay. Oh, wow. I should not have that. I'm looking for the Edmodo code, just so you know. I'm not just being silent for no reason. Let's see here. Here we go. Spring 2017. I don't think I have spring 2017. No, it doesn't look like I have the Edmodo code for this. Maybe I actually have it on Edmodo. Nope. No, it does not look like I have the Edmodo code. I would ask Mr. Dubik that on Monday, just so you have that. And that way you can submit things. The middle school mentioned that there was a Google Classroom thing, so maybe that's what he means now, and maybe this just hasn't been updated to reflect that instead of Edmodo. I don't know. That last class was the first I'd ever heard of it, so I don't know what the story is with that. Anyway, let me go ahead and get the bridge design software open. Okay. Is it for the download for? Oh, I was looking for the Edmodo code for the class. Have you guys downloaded Bridge Designer yet? Show of hands if you have. Alrighty, raise your hand if you have not downloaded Bridge Designer yet and you still need to. Okay. Google Classroom. Okay, yep. That's a thing. All right. So submit it to the Google Classroom then as opposed to Edmodo. Let's see here, Bridge Designer. Whoa, no, thank you. Okay. All right, so if you are running a Windows computer, you'll be able to get Bridge Designer software here. And if you're running a Mac, you'll be able to get it there. So yeah, the winners will receive a $20 gift certificate to Adafruit. Post your scores on Google Classroom. You can submit as many designs as you'd like. Please note that the winner will have to submit screenshots showing the number of iterations in their design. It's basically how you arrived at the bridge that you won with eventually. In the event of a tie, the earliest submission wins. Alrighty. So I'll give everybody, got a couple people who need to download it, so I'll give everybody a couple of minutes to install and download and install and stuff like that. So at 8:17, we will pick things back up and go from there. Okie dokie. So let's go ahead and get started. So once you've gotten it open, you'll be greeted with this wonderful window. You can either create a new bridge design, which will create a bridge from more or less scratch, kind of, sort of. You can load a sample bridge design, which will allow you to look at some other bridge designs that exist, so that you can get ideas. And you can also open an existing bridge design if you're already working on something. Since we're going to be working anew, you're going to be setting up a new bridge. And there's a wizard that starts everything off. Not a literal wizard. I always got really excited about this stuff when I was younger, and there was an install wizard, and I thought it was the coolest thing in the world, and then I realized what an install wizard actually was, and I was a sad child, but that's okay. So yes, not a literal wizard. So it's basically just a number of steps to walk through in order to get this bridge started. One of them is reading the design requirements, which seems silly as a first step, but it's actually an incredibly good idea as a first step, because you always want to make sure that you know what exactly you're designing for. So this bridge has to be able to carry its own weight, to include the weight of the reinforced concrete deck, plus the weight of a standard truck loading, and to keep the project as low cost as possible. If you click the Help button, you can get more complete design specifications, but we're going to click Next. Oh dear. Or we're not going to click Next. Okay, I don't know what I just made. All right, I just made that. No. So my computer has this really irritating issue with this. where the screen doesn't update for this. So it's a lot harder for me to show you guys what's going on when I can't see what's going on. As you can see, once I made the window smaller and then reopened it again, all of those nodes that I clicked to create now show up. So that's not ideal. Maybe I'll just have to go through on the slideshow. Unfortunately, it's always a little bit nicer when you can do it a little bit more interactively than that, but that's okay. So you read the design requirement. If you're entering a local contest, you enter the local contest information. You guys are not entering a local contest. Anything that you create is going to be submitted to that Google Classroom. So there's no local contest code or anything like that to work with. Then you want to select the deck elevation on the support configuration. The deck elevation, as you lower the deck, let's go to a picture here. So as you lower the deck, what you're actually doing is you're lowering the bridge as well. And that makes the span smaller because the bridge doesn't have to cross as far. Because as you all well know, because you're good at looking at things with your eyeballs, this up here is a further distance than this down here, which is a further distance than this down here, which is a further distance than this down here, and so on and so forth. So by lowering the bridge, you actually make it a shorter bridge. However, that does increase the cost of the bridge pretty significantly, because the idea is they actually have to excavate the riverbanks away in order to be able to lower the bridge down to that height so that you can, have a shorter bridge. So it's a trade-off. Do you go with the lower bridge that's cheaper, or excuse me, do you go with the lower bridge that's more expensive because you can eventually make it cheaper by using fewer materials? Or do you go with the longer bridge that starts cheaper but might become more expensive because you need to use more materials in order to cross the span? Once you've determined your span, you can select different arch types, or abutments, excuse me. So you got standard abutments and arch abutments. Arch abutments are going to be arches underneath the bridge, which provide their own sort of stability. Again, your bridge is going to be a little bit more expensive if you do that. Then you can add a pier if you'd like, which is going to be this pillar in the middle. And the pillar will allow you to generate additional support for the bridge because you can bring the pier up and then build trusses underneath it. Then you've got cable anchorages. And if you wanted to anchor cables and make like a suspension bridge, you could add some cable anchorages. Then you'll notice that all of those things change the cost of the bridge. And this is an initial cost for the bridge. All of those things are going to change the cost of the bridge. You can click the little arrow in order to get a cost breakdown so that you can see how much everything costs, so that maybe it's a better decision to make the span longer because it costs so much to excavate, or maybe it's a better idea, like you've saved some money here, so you can try and include a cable anchorage so that you can have a little bit extra stability and hopefully make it cheaper, stuff like that. Once that's done, you can click next, and then you look for, next is going to be the deck. You can either use regular medium strength concrete or reinforced high strength concrete. Reinforced high strength concrete is going to be more expensive, but it's also going to be thinner and harder and stronger. So in that sense, you might be able to save yourself a little bit of money because your entire bridge will be a little bit lighter. Ultimately a judgment call. Then you'll select a starting truss template, which will allow you to basically create a little template that you can work with in order to get started on making a bridge. Then you give it a name, you hit finish, and you're off to the races. You get a few different tools on the screen, which are pretty useful. Let's see here. So you've got a little well, maybe we'll be able to see it here. Got a little window here that I'm sort of dragging around and making flip out. This is your tools window. You can draw new nodes or joints, bars or members. You can select items with the cursor one, and you can erase them with the pencil eraser. So I can go through here, and I won't be able to erase these because they don't actually, the screen is updated since then. That's not actually where the nodes are anymore, but that's okay. Excuse me, I apologize. Nodes can be drawn on the gray squares that are provided in the truss template. Now you might notice that along the bottom of the truss template, or sort of where the ground of the bridge is going to be, you won't be able to draw anything there, and that's okay. That's because they've already started for you, so that you have a starting point for your bridge. Everything else you can just do, you can just draw, the nodes that go above it or below it according to the template that you picked, and then, excuse me, then you can use the second tool, the member tool here, in order to draw between nodes, so that you have, I see, I found some of them. Draw between nodes so that you actually can get started on the structure of your bridge. And as you draw this stuff, you will see the member list over here on the right-hand side update with various information. And this is actually very, very useful information. The material type, cross-section, size, and length, material type, cross-section, and size we're going to go over in a little bit, because those are variables that you can change on the bars in order to make them stronger or weaker / cheaper. Then you've got length, which is pretty self-explanatory. It's just how long a particular bar is. And then you've got slenderness, and the slenderness is the ratio of the size to the length. So a higher slenderness means that you have a thinner and longer bar, which means that it is going to be probably more unstable. In fact, definitely more unstable than a shorter bar would be. It would be a weaker bar necessarily, just by how physics works. But that's not always a bad thing, because having a longer bar can also mean that you've used fewer nodes, which nodes cost $1,000 on their own. So if you've used fewer nodes, which may save you a couple $1,000s, and it allows you to sort of be a little bit more economical with the design of your bridge. Then these last two, compression force strength and tension force / strength, won't come into play until you basically finish drawing the bridge and run your first simulation. So with that in mind, why don't you go ahead and finish drawing the bridge. Basically just fill in all the little nodes on your template with the node tool, and then once all the nodes are created, go ahead and use the member tool to draw between the nodes and basically trace along the light gray lines of the template. again, this is one of those things I really wish I could show you, um, but it's just really not cooperating with me, so I won't be able to. And like I said, as you create new joints and members and all that good stuff, you will get items that appear on the member list on the right hand side. You can select members and joints by clicking on them, or you can select members by clicking on the member list over here on the right hand side. So there are two separate ways to do it. Sometimes it's a little bit easier just to select them from the member list for reasons that you'll see in a minute. So I'll give everybody until like 8:33 to finish out their bridge, and then we'll go over simulating and costs and stuff like that. So yeah, see you again in a moment. Just finishing the bridge as according to the template that you provided, but we can actually make some more progress from here. So once you're done drawing your bridge, you're just going to go ahead and you can just click on the simulation button up here. Okay, cool. And the simulation button is this sort of predominantly blue square with it's a couple of downward pointing arrows and a truck on a bridge, and just go ahead and click on it, and yours should not yell at you like mine is yelling at me, and that's because I can't finish my bridge. Oh no, you're fine. You're fine. No rush at all. I just wanted to make sure everybody was on the same page. I wasn't. There was more or less just a time limit anyway. It wasn't like I was waiting for hands or anything. But you will see a nice little 3D representation of of your bridge, and then it'll settle, and then a truck will try and drive across it. Now, that second part might not happen if in the process of settling, any of the members on the bridge get damaged, in any significant way. So if that happens, or if the truck tries to drive across and it fails, that's okay. Go ahead and click the design button again, which is actually right next to the simulation button, and it's going to have the little square and the ruler and everything like that. And you'll see under your member list, you're going to have all of your listed members and everything like that, but some of them are going to have red and some of them are going to have blue. Or you might just have only red, or you might just have only blue, but whatever. Chances are you're going to have some colors, because it's not often that people pass on their first try with the stock bridge. Now the red means compression, and the blue means tension, basically pushing versus pulling. If it's blue, it means that it's experienced a statistically significant amount of tension force, and if it's red, it means it's experienced a significant amount of compression force. The deeper the color is, the stronger the force is, and the more ultimately damaging to the bridge it is. You might have noticed, if you ran along a lot of the default options, you might have noticed that the top of the bridge experienced so much compression force that the bars bent, and it turned a very deep red. That's kind of what I'm talking about there. As the colors get deeper, you might get more of a it basically represents more force. And as you look at these last two columns in the member list, you'll see the values run from 0 to some value, probably over 1. What you want to do is you want to make sure that it's below 1 as much as you possibly can. If it squeaks under just barely at like 0.99, that's okay, and technically it works. But ideally, the lower the number is, the better off you are, because at 1, that's the failure point. Yeah, you want to make sure that sort of those are, if your bridge fails at any point, those are going to be your starting points. So let's say your bridge failed. What exactly can be done about it? Well, a few things. First off, we can change the properties of we can change the design of the bridge, so we can add or remove nodes, change the add or remove structure to the bridge, things like that. If you've ever played a bridge builder game like Polybridge or anything like that, you're probably gonna be pretty familiar with that concept, where you just need to reinforce it with more trusses or something like that. However, this bridge builder software is meant to be as close to sort of real life as possible. And to that end, you also have more control over individual bars or individual members. So you don't necessarily need to add more structure. You can change the properties of members of the structure so that it's stronger or cheaper. And there are a couple of different things you can affect. If you click on a member, either in the member list or on the actual bridge itself, you've always seen these three drop-down menus have always been up here, but you can start affecting those members with those items in the drop-down menus. The first menu, as labeled carbon steel, maybe, if you click on it, you've got carbon steel, high strength, low alloy steel, and quenched and tempered steel. These are different materials that the member can be made out of. The carbon steel is the cheapest one. It's also the least stable. And then each one goes up in cost and strength. Then you've got solid bar or hollow tube. This one admittedly is not going to make your bridge any more stable. However, it can potentially make your bridge cheaper. So imagine you cut one of these bars in half and you're looking like, like a tree or something like that, and you were looking at it at the cross section head on. If it's a solid bar, it's just going to be metal all the way through. If it's a hollow tube, it's going to have air in the middle. What this accomplishes is it makes a member, if it's a hollow tube, it makes it lighter, but also perhaps more significantly for the contest, it makes it cheaper. Making it lighter also by extension can make the bridge cheaper because the bridge overall becomes lighter, which means that it needs less reinforcement. However, generally, unless you're placing the hollow bar in an area that already really doesn't need as much strength, the amount of strength lost by making it hollow does not outweigh the amount of weight and cost reduced. So that's just something to keep in mind. Hollow bars are very good for members that are already pretty well sort of stable and strong. You can afford to turn them into hollow bars to make maybe things a little bit easier for the other stress points on the bridge, and to make a stable bridge cheaper. And then the last one is probably labeled 140 by 140. And if you click on that, you just got a whole bunch. 30 by 30, 500 by 500. There's just a whole selection of different values in that one. That one is by far and away the most lengthy drop-down menu, and that's going to be the cross-sectional size. So again, when we're looking at the cross-section, we can make it either a solid bar, solid metal all the way through, or we can make it a hollow tube, so it's got air in the middle, and we can also change the size of that cross-section. So we can make the bar thicker or thinner. And what that's going to do is that's going to affect the slenderness value over here on the right-hand side, because remember, the slenderness is the size of the bar versus the length of it. The lower the slenderness value is, the more stable the bar is going to be. It's also going to be more metal, which means more weight and more cost. However, this is a very good way of reinforcing the strength of an individual member so that you have a stronger bridge overall. So again, these are all just sort of food for thought. Now, if you've run your bridge through the simulator and then went back to the design mode and you're looking at your picture of the bridge, you're going to see probably some blue and red hash marks on individual members where the bridge failed. These are definitely going to be your starting points. So you can select a couple of, maybe like the two outer truss members, and you can make the cross section larger just by 10 centimeters. So it becomes 150 by 150 instead of 140 by 140. And maybe the middle top truss, the one that bends, you can change that to like 170 by 170. And if you run the simulation again, you'll see that the bridge will still fail, but it'll fail in different places. And maybe it'll last a little bit longer before it fails. And that's the whole idea behind this, is basically you just start and you iterate and you iterate and you iterate. And so you can check your member list to get an idea of where things are failing and how badly they're failing. The further above one you have, the sort of the worse off the particular member is, and the more work it's going to need in order to get to a stable value. And the lower the number is, maybe you can look at reducing the cost by turning the bar hollow or shrinking the cross section. Increasing the quality of the steel used is also a very good way to increase the strength, but keep in mind that the cost of the steel does increase pretty significantly pretty quickly. So as you can see, carbon steel is 2,646. But if we change it to quenched and tempered steel, it's up to 3,692. So obviously, it's your call to see whether or not the increased cost is worth it, because that cost is for that entire member. So obviously the price difference is going to vary by length and by thickness of the bar, but sometimes it can be really worth it to have a smaller reinforcement member that takes a lot of strength and turn it into a really high quality steel, because the cost change is going to be minimal. But then sometimes, if you've got a really long bar across the bulk of the bridge, you may need just to bite the bullet and turn it into a higher quality steel, even if it's going to be significantly more expensive, just so your bridge stays standing. Anyway, that's the whole idea behind this bridge building software, and we can go more into the math on it and things like that on Monday. But as it stands right now, I think I'm going to go ahead and call it a day, because there's not much more I can teach you at this point, and I think I need to nurse this headache of mine. So I'm going to go ahead and skip the poll questions, and we'll leave it open for question and answer time. If you guys have anything, I'm here. Otherwise, you're more than welcome to head out and enjoy your weekend. I mean, you've still got the rest of your week, but enjoy the rest of your day a little bit early. Maybe get some homework done or something like that, if you've got pressing assignments. But certainly I'll turn you guys loose a little bit early. So like I said, if you have any questions, I'm here. Otherwise, you're more than welcome to head out and have a wonderful day, and have a wonderful weekend, in fact.